All right, this is for Physics CP. It's January 26, 2021. This is the answer key for the 3-page homework assignment that I had posted that's due. A 25 Newton force pushes a block across the surface for 6 meters. How much work is done by the applied force? All right, so I have a surface, I have this block, I have a force that's being applied. By convention, direction of motion is to the right unless stated otherwise in the problem. This force has a magnitude of 25 newtons. The distance that it travels is 6 meters to the right. I'm going to ask you to calculate everything to at least 2 sig figs. 3 would be even better. The formula for calculating work is force dot displacement. In this situation, that means a force of 25 newtons times a displacement of 6 meters times the cosine of the angle between these two directions. The force was to the right, and the displacement was to the right, and the angle between to the right and to the right is 0 degrees. The cosine of 0 degrees is 1. So the result, you can almost do it in your head, 25 times 6, beep, beep, beep. The work done is 150 joules. Number 2. If, in the previous question, there is a 15 Newton kinetic frictional force opposing the motion, how much work is done by the force of friction? And then, does friction do positive work and negative work on the block? Draw a free body diagram to support your answer. Here's the block. Of course, the free body diagram would show there's the force of gravity acting down towards the center of the Earth, an equal magnitude opposite normal force canceling the force of gravity. There's the applied force of 25 newtons to the right, and then there's the kinetic frictional force of 15 newtons acting to the left, always opposing the direction of actual or attempted motion. In this problem, the first question is how much work is done by the force of friction? Well, the work done by friction is equal to the force of friction, which is 15 newtons, times the displacement. So friction actually goes based on distance, not displacement. The point being, if I had a displacement of 10 meters to the right, followed by a displacement of 4 meters to the left, then I would actually calculate the distance traveled, not the displacement, when calculating the work done by friction. That's because when it's moving to the right, friction does negative work over the entire distance. When it's moving to the left, friction is still doing negative work over that entire distance because the direction of the force of friction is always opposite the direction of attempted or actual motion. In this problem, we're only aware that it goes strictly to the right, and it went strictly to the right a distance of 6 meters. The angle between the direction of the force of friction to the left and the direction of actual or attempted motion to the right is 180 degrees. The cosine of 180 degrees is negative 1. So when you multiply 15 by 6, you get 90, but the minus sign means negative 90 joules of work done by friction attempting to stop this block from moving. How much work is done by the force of friction? The answer is negative 90 joules. Does friction do positive work or negative work on the block? Negative work. Friction only does negative work. Friction only does negative work. And here's my free body diagram. Number 3. A forklift applies a force of 2,000 newtons, again, pretend it's 2 or 3 sig figs, to raise a box 3 meters. How much work is done by the forklift in raising the box? Well, the force is 2,000 newtons. And the distance that it moves is 3 meters. The work done by this force is the product of the force, 2,000 newtons, times the distance that it moves, 3 meters, times the cosine of the angle between these two directions. The force is upward. The distance moved is upward. The angle between up and up is 0 degrees. The cosine of 0 degrees is 1. So 2,000 times 3 means the work done is a positive 6,000 joules, or 6.0 kilojoules. Going to do it to 2 sig figs. Number 4. If a box weighs 1,500 newtons, oh, by the way, if the box, so this is a continuation of question 3. If the box weighs 1,500 newtons, how much work does the force of gravity do on the box? Is the work positive or negative? Draw a free body diagram to support your answer. So here's the box. The upward force was 2,000 newtons. I'll call that the applied force. The force of gravity was 1,500 newtons, and that's a downward force. The direction of motion is actually upwards in the amount of 3 meters. To calculate the work done by the force of gravity, I multiply the force of gravity by the distance that it moves by the cosine of the angle between the two directions. The force of gravity is vertically downwards. The direction that the box moves is vertically upwards. The angle between down and up is 180 degrees. The cosine of 180 degrees is -1. The work done by friction is therefore negative 4.5 kilojoules. I'm sorry, not the work done by friction. The work done by gravity is negative 4.5 kilojoules. Number 5. Using the information from the previous 2 questions, what is the total or net work done to the box? The net work is the sum of all the work done on the box by the various forces. In this case, from problem 3, I have positive 6.0 kilojoules done by the forklift, and I have negative 4.5 kilojoules of work done by the force of gravity. So the net work done on the box in this situation would be 1.5 kilojoules. Or kilo, of course, means 1,000, 1,500 joules. And that is a positive quantity. And by the way, if the box started from rest, we could calculate, based on its known weight, what the mass is of the box. We could then apply that into the kinetic energy formula and calculate the speed that this box is moving at the moment it passes through a height of 3 meters. But they're not asking that, so let's just stick with the homework for now. Number 6. A 50 Newton block is raised 2 meters. If the net work done on the block is 50 joules, what is the applied force on the block? Well, the formula is work done is the dot product of the force and the displacement. In this situation, we're rearranging the equation to solve for the force. The applied force would be the result of dividing the net work done on this box in problem 6 by the distance that it was raised. So I used x thinking generically in the horizontal direction. Because this problem is in the vertical direction, I'm going to replace the x with a y and list this as delta y. The work done was 50 joules. And again, override the 1 sig fig, do everything to 2 or 3. The distance raised was 2 meters. I should really say that this is the net work done, net force acting on the box. The net force is equal to the net work divided by the displacement. So 50 joules divided by 20 meters, beep, 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 means the net force applied was 25 newtons. Now, in terms of a free body diagram, I have the weight of the box, the force of gravity, listed as 50 newtons. The applied force is unknown. But when I add these two together, my net force is 25 newtons upwards. So as an Algebra 1 problem, I could say that negative 50 newtons, the weight, added to the applied force, which is a positive number up, add together to the net force of 25 newtons upwards. Solving for the applied force, I add 50 newtons to both sides, and I get an applied force of 75 newtons. Page 3. Number 7. Part A. A 25 Newton block is lowered 1.2 meters by a 20 Newton force. Draw a free body diagram of the forces acting on the block. Here's the block. The force of gravity is downward and has a value of 25 newtons. The tension in the rope, I'll call it, is 20 newtons pointing upwards. Again, override it, make it to 2 or 3 sig figs. Part A, draw a free body diagram of the forces acting on the block. This is it, and meanwhile the block physically moves downward a distance of 1.2 meters. That would be a negative 1.2 meters as far as displacements go. Part B, how much work does the force of gravity do on the box, and is it positive or negative? The work done by gravity is the product of the dot product of the force of gravity and the displacement. In this situation, the force of gravity has a magnitude of 25 newtons. The displacement has a value of 1.2 meters. And the angle between the direction of the force of gravity and the direction that the box moves is 0 degrees because they're both vertically downward. The cosine of 0 degrees is 1, and 25 times 1.2 means the work done by gravity has a value of positive 30 joules. And so this work is positive. Make it clear that you are answering the question. Positive work is done. Part C. How much work does the applied force do on the box? Well, the work done by the applied force is the dot product of the applied force and the displacement. The applied force has a magnitude of 20 newtons. It is the tension in the cable that keeps the box from just accelerating in free fall. The distance that the box moves is 1.2 meters. The angle between the direction upwards of the tension and the direction downwards that the box actually moves is 180 degrees. The cosine of 180 degrees is -1. So the work done by the applied force is -24 joules. This work is negative work. Answer the question. They ask, you answer. Number 8. Does it require more work to raise a 15 kilogram block by 4 meters or to raise a 20 kilogram block by 2 meters if both are moving at a constant velocity? Draw a free body diagram to help solve the problem. Constant velocity is telling us that we're not doing net work on the problem that is increasing its kinetic energy. So we're doing a direct trade-off between the work done by gravity and the work being applied so that it neither increases nor decreases in its kinetic energy in this problem. So I have a block. This one is 15 kilograms, and it rises through a distance of 4 meters. I'm going to compare that with a 20 kilogram block that rises through a distance of 2 meters. And try to have your sketch somewhat suggestive. This is a larger drawing than that one. This is a shorter distance than that one. This should be half that height. This should be, 1/3 greater than that in size. Something at least suggests the dimensions. To calculate the work done, of course, the free body diagram here would be the force of gravity is equal to the weight of the box. The applied force is going to be equal to the weight of the box. I say that because it's moving at constant velocity. Keep in mind that constant velocity doesn't mean that it's not moving. It means that it's not accelerating. If it's not accelerating, then the net force is 0. If the net force is 0, then the sum of all the forces acting on it must cancel. They must add up to 0. Therefore, if it weighs 15 kilograms times g, then the applied force is equal to 15 kilograms times g. And we can calculate the work done. In this case 1, I'll call it, as equal to a force equal to the force of gravity, m times g, times the distance that it rises. Now you might notice that m times g times h happens to be the formula for gravitational potential energy. That is not a coincidence. Increase in gravitational potential energy is equal to the work done on lifting this object. So there, 15 times 9.8 times 4, beep, beep, beep. I get an amount of work done of 588 joules. To 2 sig figs, I would call that 590. For case number 2, the work done, again, same free body diagram. Force of gravity equal to the weight down, applied force equal to the weight up. So m times g times h, and by the way, the direction of the applied force is up. It moves up. So the cosine is 0 degrees. The angle is 0 degrees. The cosine of 0 degrees is 1. So it's hidden in there in the formula mgh. It's really mg dot h. mg times h times the cosine of the angle between them. Okay, and they're always vertical, so it's always 0 degrees. So it's, okay, there you go. Anyways, on the calculator, this is going to be 20 kilograms times 9.80 we use in CP physics, meters per second squared, times the cosine of 0 degrees. Beep, beep, beep. And did I include the height? Of course not. Times 2 meters. Okay, so times 2 meters. And I get 392 joules. Does it require more work to raise the 15, case 1 or case 2? It requires, requires more work to raise 15 kilograms by 4 meters than to raise 20 kilograms by 2 meters. Please answer the question. Don't just do the calculation and let me, try to figure out what the numbers mean. Now I could even get specific and tell you by how much, but they didn't ask. This concludes the debriefing on Physics CP homework assignment.